Everybody, happy Thursday. Okay, so today we are continuing with systems of equations. That's pretty much all of Unit 5 is systems of equations. So we are going to take the Unit 5 test next week. On Wednesday, we're going to take the Unit 5 test. And then again, remember to be watching your email. I'll be sending out some information about semester exams and whether or not you're exempt from semester exams. Look for that next week. And also you'll be getting some information about MAP testing, MAP testing. We did this at the beginning of the year and you guys had to log in at a certain time. And so there's going to be something similar like that happening. You'll have to log in at a certain time to take the MAP test. It is required for all students in the district. You cannot get out of that. So be looking for information on both of those, semester exams and MAP testing. Both of those are coming up. Okay, so let's get started today. We're going to start off in our journal. So pause the video now if you need to and go find your journal on your Google Drive. And we are going to be looking at, let me go to the next slide here, Unit 5, Lesson 2. Should be linked to slide 25, Writing Systems of Equations. So let me bring that up. So here it is. So you're going to be typing on your slide here, and you probably need to zoom in. And remember, you can just click. I've changed the text boxes, so you'll just click and type. I'm actually going to write on my iPad because it's just going to go a little bit smoother, and I can show you guys a few more things in the problem here. So I'm going to pull it up on my iPad, and we're going to work a couple of these problems together. We're going to work this one, and then the very last slide in the journal as well. So this will conclude our journal for the 9 weeks. So next week, we also will be doing our journal quiz. That'll be another major grade. So you have 2 major test grades coming up. We have a lot of tests coming up. That's what happens at the end of semester. So journal grades coming up, Unit 5 test grade, and those will go into Skyward. And then the other tests, the last week before we get out for Christmas, will be MAP testing and semester exams. Okay, so let me pull up my iPad here. There it goes. Okay, so here's the same slide. So we're talking about how do we take a word problem, like a real life situation, and write an equation to represent it. And I think you're going to find this is pretty straightforward because we have already looked at problems like this. We have been writing equations in every single unit. So this is really not something new. So remember, because it's a system of equations, that means you have 2. So instead of us writing just one equation, now we're just writing 2 of them. Oops, at the same time. Dropped a little cap on my pencil. Okay, so example 1 here. It says Franklin is sold water bottles in 2 sizes. So it's important to note that he sold large, and they told us how much they cost. And he also sold like a regular water bottle. And then they told me he sold 113 bottles total, and he collected $221. So the question, or what they're asking us to do is write a system to represent this situation. So these notes kind of walk us through all the steps we need in order to do this. So we need to first define our variables. Because we have 2 equations we're writing, we're going to have more variables, and we have a lot of information that's really been given to us. So we need to identify all that information first. So first of all, I look and I say, well, okay, do I know the number of large bottles that he sold? Did they tell me that? Well, they told me how many bottles he sold altogether, and they told me how much money he made total. So they gave me 2 totals, the total bottles and the total money. This is very common when you see systems of equations and we're writing 2 equations. They usually will give you 2 totals. You'll be writing 2 equations, one to represent one of the totals and one to represent the other total. It's very, very common. So I do not know how many large bottles he sold, but I do know how much the large bottles cost. They cost $2.50. And I don't know how many regular bottles he sold, but I know they cost $1. So because I don't know the number of large bottles, that's a question, I am going to use a variable to represent that. Remember, we use variables to represent numbers we don't know. I don't know that number, so I don't know. I think I'll pick L. That's a good variable. Do I know the number of regular bottles? No. So again, I'm going to pick a variable. I'll pick R. Do I know the total bottles sold? Well, yes, I do. I know that he sold 113. Do I know the cost of a large bottle? Yep, they told me it was $2.50. I know a regular bottle cost $1. And I know his total money. They told me that. It was $221. So that's a lot of stuff I do know. This is the information we're going to use to write our equations. So write an equation to represent the total amount of bottles. Oh, okay. So I know the total bottles was 113. So I want to represent that. Well, that's the total bottles that he sold was the large bottles and the regular bottles, right? And I don't know what those numbers were, but I do know I'm going to represent them using large bottles and regular bottles. So if I knew the number of large bottles, L, and the number of regular bottles, I'd add them up and I should get 113. We're done. We've written an equation. The next one says we'll write an equation to represent the total profit. Okay, I do know my total profit. It was $221. So I'm going to represent that with an equation. Well, I know that my large bottles cost $2.50. So if I took that $2.50 and I multiplied it times however many large bottles I sold, and then I added it to the $1 we made for every regular bottle we sold, I should get the total $221, right? Because if my large bottles cost $2.50, and if I sold, I don't know, 10 of them, well, I would say 250 times 10. So that's why I said the 2.5 times L. So this is really common. There are our two equations. Now it says put them together to form the system. So literally all you need to do is write them down together. 2.5 L plus, and I'm not even going to write the 1. I'm just going to write R equals, oh, I forgot a 1 up there, 221. Done. That's it. The last step here is just for you to understand you're writing two separate equations. When you put them together, you have a system. So, like again, this should not be too hard. The important thing is that you need to remember is if they give you a cost, be sure and put it beside the variable for that one. Don't mix up your cost. Remember, the cost for the large bottle was $2.50, so that's why it's sitting beside the L. Okay, well, let's look at one more examples together. So this one says Joe, he had a coin collection, and in his coin collection, he apparently had some dimes and some quarters. He has 200 coins total. I don't know how many of those are dimes and how many are quarters. And I know he has a total monies worth of $32. Write a system to model equations to model the situation. So let's define our variables again. Do I know how many dimes he had? Nope. And I also don't know the number of quarters that he had. They told me the total number he had was 200. So I know my total coins is 200. I don't know how many dimes. You know what? I think I'm going to use a big D to represent that then. And I don't know how many quarters. So I'll just use big Q. So I have some dimes and some quarters. And if I added those up, I would get 200. Do I know the value of a dime? Of course I do. I know a dime is worth 10 cents. Now, I do not want to write the number 10 because that would mean that I'm multiplying it by like 10. So if you're talking about money, we think in terms of dollars. So that's not going to work. So remember, when you're using coins, change in a word problem, you have to use it as a decimal. So that's 0.10, right? I know the value of a quarter. It's 25 cents. So we have to represent that as a decimal, as 0.25. So do I know the total value? Yeah, he had $32 worth. And see, now this is why I had to represent those as a decimal, because I have $32. So I'm writing my money in terms of dollars, not cents. Okay, so write an equation to represent the total amount of coins. Well, that's easy. I know that if you add up your dimes plus the number of quarters you have, we should get 200 coins. Well, now and then it says write an equation next to represent the total value. Okay, so I know the value is $32. So I know if I took 10 cents for every dime he had, plus I multiplied every quarter he had by 0.25, I should get $32. So again, notice that the value is sitting next to the variable that represents the number of that. So the number of dimes, D, 0.10 has to be by the D. So then it says literally put it together. Write down your system. Well, I have dimes plus quarters equals 200. And I have 0.10 D plus 0.25 Q equals 32. I'm done. That's all it wants me to do. Put them together, write the system. So notice that we're not asked to solve anything here. We're simply just writing them from the problems. We're going to come back tomorrow and we're going to write them and solve them. But for today, I'm just been asked to write them down. I just want to be able to take the verbal description they're giving me of the situation that's happening and write it in equation form. So we're going to practice this some more by going over to Canvas on the modules page today. At the very bottom of the page, let's see if this will load. We're going to do this task right here, writing systems of equations in various forms. So this is really, really similar to what we were just looking at together. Let me open up a new thing here because I think I need a blank. There we go. Okay, so we're going to click. It's not a quiz. It's just an assignment. You know, Canvas calls everything a quiz pretty much. But that doesn't mean it's a quiz grade or a test grade. So here's a scenario. Julio bought tables and chairs for his restaurant. He bought 16 total items and spent a total of $1,800. Each table costs $150 and each chair costs $50. That's about right. Let X represent the number of tables and let Y represent the number of chairs. Okay, so I think I'm going to try and do this like side by side if my computer, because I want to bring up, really need to write on this for you guys. Be okay. It may not let me do it. Sometimes my thing, it doesn't let me do what I wanted to do. Oh, no. Put it back over there. Okay, so now let me bring up my iPad on this side because I want to be able to write as we work this problem. It's not going to cooperate with me, guys. Okay, so Julio bought some tables and chairs for his restaurant. So we're asked to write an equation. Now, the thing about these problems right here is there's, y'all, my computer's like completely froze up there. There's more than one correct answer. So there's one equation that we're going to write it. But then notice what they've done really, and we'll see in a minute after we've written it, is they've kind of rearranged some of the equations. So some of these are equivalent and still do describe the situation. So what I find is easiest to do is we're going to write them just like we wrote the ones in our notes. Then we're going to come back and we're going to see which ones are equivalent, which other ones. We're going to find the original one. Man, this is not moving, guys. Okay, there we go. I'm having trouble here. Okay, so let's note, and this is good to do like on a piece of scratch paper. They told us that X is going to represent my tables. And they said Y needs to represent chairs. So that's important that we keep those straight. So write that down somewhere so you can keep it straight. Write down that X, as it says, X represent tables and Y is going to represent the number of chairs. So they told us he has 16 total items. That's tables and chairs together. So we know that his tables plus his chairs together should equal 16. Now they gave us another total as well. They said the value is a total of, he spent a total of $1,800. So that's where I would put my other total, $1,800. Now they said each table cost $150 and each chair costs $50. Well, remember how I told you the value needs to go next to the variable that represents it? So if the tables are $150, those are X. So I need to write 150X plus, because this one's representing our money, $50 times every Y, times every chair. There's my two equations right there. Now, do you see how A is sticking out? It matches perfectly. X plus Y equals 16. That's tables plus chairs is a total of 16. And if I'm trying to figure out my total money, well, it's $150 for every table and $50 for times every chair equals the $1,800 that he spent. So now what I need to do is I need to look and see if any more of these are equivalent. So let's look at B. Notice the only difference between B is the first equation. This one says X plus Y equals 16, but this one says X equals 16 minus Y. So sometimes we don't even have to do any work. We can think about this. If X is tables, it says if I take my number of tables, it's going to be equal to the total 16 minus however many chairs I have. So it's saying my number of tables should be the total number of items I have, take away chairs. Now, hopefully that makes sense. But you can always come over here And I'm going to erase so that I have more space here on this side. You can always come over. Let me put that back actually. X is tables and Y is chairs. You can write it down on your paper and rearrange it and see if it's true. Let me let my iPad catch up here. Okay, so we have the first equation, which is x plus y equals 16. So if I drew my line and I solved it for x, because I'm seeing that's what's happening here in B, well, I would have to subtract a y on both sides, right? So positive y minus y would cancel out, and I would have x equals 16 minus y. Well, is that what this one's saying? Yes. So B is also equivalent. I don't know why these are mixed up, guys. These should not be mixed up. I'll try to fix that. So B is also equivalent. Okay. The next one we have is y equals 16 plus x, and then 150x plus 50y equals 1800. Notice the only thing that's different is the first equation again. The second equation is the same. Okay, so let me go back over to my iPad. Let me write it down. The first equation again. Well, I have x plus y equals 16. So this one is saying that y would be equal to 16 plus x. Is that true? So if we were to solve for y, well, x is positive, right? So to move it to the other side, I would have to subtract an x. So that's not going to be equivalent because that would be 16 minus x. And this is saying 16 plus x. This is saying the number of chairs I have is equal to 16 plus however many tables I have. Well, that shouldn't make sense because 16 is the total number of tables and chairs I have together. So I wouldn't add my tables to it to get the number that I have chairs. I would have to subtract them. So C is not equivalent. So now we need to look and see if D is equivalent. Well, I'm noticing that the only difference between A, our original that we said was true, and D is the second equation, because this was still x plus y equals 16. So now I need to figure out if they've moved around the first equation, the second one, I'm sorry. So I'm going to write down the second equation this time, and I'm going to rearrange it and see if when I solve it for a variable or rearrange it, if that's equivalent to what they have on D. So our second equation was 150x plus 50y equals 1800. Okay, so I can see here that it looks like what they tried to do was they tried to get this 50y by itself. So that's what I'm going to do over here. I wrote that too far over. So if I want this piece right here by itself, well, I got to subtract the x term. So because it's positive, I would subtract 150x. So that's gone, and I'm left with 50y equals 1800 minus 150x. Remember, those are not like terms. We can't combine them. My iPad's just really lagging. So then I'm going to look and see, is that equivalent to what they have over here for D? They have 50y equals 1800 minus 150x. Yep, that's what we got when we moved it over. So that one is also equivalent. Let me bring it back full screen. So D is also equivalent. I think this is shuffling the answers, but I'll turn that off. Yours should be in order A, B, C, D when you do this assignment. Okay, so I know that was kind of tedious, but I think once you get down to the end, you're going to be like, oh, I can see. Because remember, if we need to move something over and it's positive, we're going to end up subtracting it. So if we're going to move y over, we would subtract it. So that's why this one was true. But this one, C can't be equivalent, because if we were going to move our x term over, we would have to subtract it, and this one's added on this side. So this is to try to help you see that you can write them in one form, but then you can still rearrange the equations, okay? So you have 12 problems to work through here. I just worked one of them with you, but they're all very, very similar. So start off by writing your equations that represent each total, represent total money, and here we represented total items. That's usually what it's going to be. One's going to be total money, one's going to be total items. So you have two totals that you're trying to represent an equation. Then see which ones are equivalent and be sure and check all of them that are equivalent.